In this module, we are going to be talking about the idea of confounding. This is a really important concept in terms of public health research, especially when we're thinking about observational studies in which confounding can be a really big issue. There are multiple challenges to the validity of studies. When we're talking about validity, what we're thinking about is how well a study actually measures what it set out to measure. There are other challenges besides confounding in terms of validity. We are going to talk about bias in more detail during the rest of this class, but for the purpose of this module, we are really going to focus on confounding. When we're thinking about bias, there's essentially three sources of bias. The first is selection bias. The second is information bias. We will talk about these later on in the quarter. But for today's lecture, we're going to talk about confounding, which can cause us to get biased results. And so it's something we really have to think about and account for in order to make sure that we're getting results that aren't biased by the presence of confounding variables. Confounding is this phenomenon that happens that you can think of as kind of annoying background noise that impedes your ability to quantify the measure of association between an exposure and an outcome variable. So remember, in health research, we're typically trying to measure the relationship between some exposure variable and some outcome variable. So maybe that's smoking and lung cancer, maybe it's physical activity and heart disease. Regardless of whatever that relationship that you're looking at is, confounding is where we have this mixing of effects. Essentially, we have this third variable that exists that is distorting the true relationship between our exposure and our disease that we're looking at. It is something that is present that's causing us to get a biased measure of effect. So we're getting a biased odds ratio, a biased relative risk because of the presence of that third variable. So an example of this might be a researcher is looking at the relationship between alcohol and lung cancer. Maybe they're finding that there's this relationship. They keep seeing this positive odds ratio that is showing that that alcohol consumption actually does increase the risk of getting lung cancer. Well, you might want to think about, is there some other variable that is present in this study that could potentially affect why I'm seeing this relationship? And we'll talk about that with an example on the next slide. So there are some very specific characteristics of a confounder. In order for a variable to potentially even be a confounding variable, that variable, it has to be associated with our exposure variable, and it also has to be associated with the disease variable or the outcome variable. So this third variable, whatever that variable is, it has to be associated or related to our exposure, and it also has to be associated or related to our outcome variable. If a variable is only related to one of these or it's not related to either one, it cannot be considered a potential confounder. We would not consider that variable to be a potential confounder in our study. The other really important definition or characteristic, I should say, of a confounder is that it can't be a biologic consequence of the exposure. So it can't be a direct result of that exposure variable. So for example, if this variable here is something like fat consumption, your potential confounder can't be cholesterol level because fat consumption is going to directly result in your cholesterol levels. That cholesterol level variable would fall on this causal pathway and therefore would not be considered a potential confounder. So here's an example. Let's say I am interested in looking at the relationship between exercise and having a heart attack. maybe I hypothesize that people who exercise are going to be less likely to have a heart attack. Now, if I run that analysis, I might find that there's some sort of association that I observe between this exercise variable and this heart attack variable. But the issue is that the age distribution of people who exercise, there might be an association between age and exercise, meaning that potentially people who are younger might exercise more than people who are older. There's going to be a relationship between age and exercise. And there's also going to be an age association with having a heart attack. So in other words, age is going to be associated with the chances of having a heart attack. Now, given that this variable is associated with our exposure, it's also associated with our outcome, and it is not a biologic consequence of the exposure, meaning that exercise doesn't result in age. So age doesn't fall on this causal pathway. This would be an example of a variable, age, that could be considered a potential confounder, given that it has the characteristics of a potential confounder. So we see a lot of these different examples in the data, and they're often an explanation. Their presence is an explanation for some of the associations that we do observe. So given that a potential confounder has to be related to our exposure, it has to be related to our outcome variable, and it can't be on that causal pathway as a biological consequence of the exposure variable. One of the things that I typically do when I work on a research study is I will set up my table 1, which is usually in a research study, it is a table that summarizes the characteristics of the sample of that study. And I will typically look to see, are my variables that I have collected information on, are they associated with the variable that I decide to display my results by in this in that research study? So this table is actually a real example from a paper that I published. It looked at, for the independent variable, it looked at race and ethnicity as that independent variable, and the outcome variable we were interested in looking at, we looked at the relationship between race ethnicity with whether or not someone was denied health or life insurance. So our independent variable is race ethnicity. Our outcome variable is the denial of health or life insurance. You can see these variables that we looked at in terms of the demographic variables. Those are listed here, those characteristics. And what you can see is that we displayed those characteristics by those who were denied insurance, so those who have the outcome of interest. And then we also displayed those who did not have the outcome of interest, which are those who were never denied insurance. And what you can see here is the p-value. So basically, we're looking to see, are there statistically significant differences between these characteristics and our outcome variable? More specifically, what we're looking at is there an association between these characteristic variables and our outcome variable? And what you can see is that some of these were statistically significant in terms of their association with the outcome, but some of them did not have a statistically significant relationship with the outcome variable. So what we saw is that variables like sex, age, we also saw income and employment status, these were related to our outcome variables. So given that, we can conclude that those variables do have a relationship with the outcome variable. What this actually tells me is that when I run my analysis looking at the relationship between race and ethnicity and whether or not someone was denied health or life insurance, what this means is I should not consider variables like education, marital status, or number of cancer diagnoses. I should not consider these variables as potential confounders because they don't have a relationship with the outcome variable. So I can automatically deduce from this table that I should not consider those specific variables, education, marital status, and number of cancer diagnoses, as a potential confounder because they don't have a statistically significant relationship with my outcome variable. So it's really important to determine what variables are potential confounders in your data. Oftentimes, we will actually calculate associations between our variables and our exposure and outcome variables, similar to what I just talked about in the previous slide. But sometimes we actually just review the literature and we look at, based on the literature, what variables have been shown to be associated with the exposure and the outcome variable, and they are not going to be on that causal pathway. Whatever variables you consider to be potential confounders, one of the really important pieces of confounding is that it is this issue, it's this phenomenon that we identify in our studies that needs to actually be addressed.